Hello and welcome friends to our first problem solving session related to gravitation. As you all know, our first three problem solving sessions would be of level 1, that is we are going to discuss some board level questions. Is this fine? Okay, so let us straight away start our today's session with the first problem that is right on your screen. Now, according to this problem, we need to choose the correct alternative. The question given to us is acceleration due to gravity, whether it increases or decreases with the increasing altitude. Now, basically friends, first of all, as we always do, we are going to draw a diagram. Suppose this sphere that I have drawn is our Earth. Now this is surface of Earth, and what do we know that on surface of Earth the acceleration due to this gravitation is known as acceleration due to gravity. Now basically the question is, what happens if we increase the altitude? That is, if we are, say for example, above the surface of Earth at a height, that is from surface of Earth h, whether if we are over here. Now what is the acceleration due to gravity? Whether it increases with the increasing altitude or it decreases. Now what is the answer? Yes friends, now as we have discussed in our theory session, what do we know? That acceleration due to gravity at some height h is equal to, yes friends, now there were two derivations, or basically what we came across. First of all, let me write down of the surface of Earth. So gravitation or acceleration due to gravity on the surface of Earth is equal to gm by r square. Is this fine? Now r is the distance of the object from center of Earth. This is pretty much clear to each and everyone. Now basically when we talk about the surface of Earth, that is when we calculate the acceleration due to gravity on surface of Earth, there is a precise or a specific condition that this r becomes the radius of Earth. So when we talk that acceleration due to gravity, then it becomes gm by re square. But the general formula for acceleration due to gravity is gm by r square. So if now we calculate that acceleration due to gravity on a height h, that is above the surface of Earth, then what are we going to get? Yes friends, r would be the distance of the object from surface of Earth. So in this particular case, this diagram you can simply write down, let me write it down over here, that this object acceleration due to gravity, I said g dash, will be equal to gm by r square. R is the distance from the center of Earth, that is this whole distance is our r, or I can write it down simply re plus h whole squared. Is this fine? So one thing is for sure, if you compare these two formulas, this is, let me say, equation 1, this is, let me say, equation 2. Then from here itself we can see that as the denominator is increased, this term is going to decrease for sure. Is this fine? Yes or no friends? Or let me prove it on the whiteboard over here. What do we know now? G dash is basically equal to gm upon re plus h whole square, or this can be written as gm into re plus h upon, or raised to the power minus 2. Is this fine? Or basically in this equation only, if we take re out of this bracket or out of this term, then we can write it down this as re square. This will be 1 plus h upon re whole squared. Is this clear to everyone? Okay friends, so similarly, instead of writing this equation, we can directly write that this will be gm upon re square. This will be 1 plus h upon re whole raised to the minus 2. Now what do we know? Gm upon re square is acceleration due to gravity on surface of earth, which we know is equal to g, whose value is 9.8. And from binomial expansion, I can write down this as 1 minus twice of h upon re plus now all those terms, that is the squared and the cube terms or the powers of this h by re, as h is very small, the square will be even smaller, so I can neglect the rest of the terms, so I can write down this whole equation in this way. Is this fine? And from this only you can now betterly understand this g dash will be equal to g 1 minus twice of h upon re. Is this fine? So basically there is only one formula, the difference is writing it in two terms. Now this equation comes into consideration when h is comparable to radius of earth. In that case we do not neglect those powers. Is this fine? But if you say that the height above the surface of earth is negligible, or if it is some few meters or kilometers, then we can neglect the powers of this h. So in that case we write this equation, or this equation comes into consideration when h is very very small compared to your radius of earth. But in both the cases, our simplest question, okay, what is going to be the acceleration due to gravity when we are increasing the altitude? In that case, for sure the acceleration due to gravity has to decrease. Is this fine? So the correct answer for this question is it decreases with increasing altitude.